In this lesson, we're going to work on solving a system of two equations using elimination. So let's take a closer look at my two equations. So let's name the first one to be equation number 1, the second one to be equation number 2. Your main aim when you're solving using elimination is to eliminate one of the variables. Now let's see which one is easier to eliminate. This is going to be 4x and this is 3x. So in order to be able to eliminate this, you need to multiply the top by a 3. So 3 times 4 would be 12. The bottom, you'd multiply it by a -4. -4 times 3 would be -12, and then you can eliminate these. Now let's look at the y's. So equation number 1, equation number 2. If you look at the y's, I can see that the top one has a coefficient of -5. The bottom has a coefficient of 10. So basically, I need to multiply this one by 2. 2 times -5 is a -10, and then I can add the two equations and they will cancel. So if I choose to eliminate y, I will have to do less work. I will only have to multiply the top by 2. Whereas if I want to eliminate x, then I have to do more work. I need to multiply the top by 3 and the bottom by -4. So I choose to do less work and eliminate the variable y. So let's go ahead and write step number 1. Let me just delete this. Let's go ahead and start on step number 1. And my step number 1 is I choose to eliminate y by multiplying the top part by 2. So let me copy the equation. I'm going to multiply this by 2. So it will become 8x minus 10y equals 46. And I need to copy the second equation under it. Now if I try to add these two equations, 8 plus 3x, that's going to be 11x. The -10y and plus 10y, they cancel out. 46 and 31, that's 77. So there you go. I just eliminated the variable y. Now the second step, I need to solve this resulting equation by solving for x. If I divide both sides by 11, I get x to be equal to 7. So I just got the first variable. Now to get the second variable, you need to plug this value in any of the original equations. So let's say you choose to plug it in the first, which is 4x minus 5y equals 23. So 4 times 7 is going to be 28 minus 5y equals 23. And then you need to subtract 28 from both sides. So you get that -5y is equal to -5. If you divide both sides by -5, you solve for y, which is 1 in this case. So my solution is 7, 1. Now to check if your solution is correct or wrong, you need to plug it in both equations. So go ahead, copy the first equation down. And plug in 7 for x and 1 for y, and check, is it going to give you 23? 4 times 7 is 28, minus 5 times 1 is a 5, and yes, it will give me 23. So once you plug it in the first equation, you see that your solution is correct. Now let's go ahead and plug it in the second equation, and my second equation is 3x plus 10y, and I need to check if it's going to give me 31. So 3 times 7 plus 10 times 1, is it going to give me 31? So 3 times 7 is a 21, plus 10 times 1 is 10, and that's going to give me 31. Yes. In this case, my solution 7, 1 is the correct solution. So remember, every time you have a system of two equations and you choose to use elimination, you need to choose to eliminate the easier variable. In this case, it is y. Now let's take a closer look at the same system. Let's take a closer look at the same system. Okay. Now, do you think substitution was a good method? Do I see a variable having coefficient of 1 or a single variable? I have a coefficient for x, a coefficient for y, coefficient for x, and coefficient for y in the second equation as well. So I do not have a single variable, so substitution is not a good method. That's why you choose or resort to elimination. Now let's go ahead and move on to our second system. And let's take a closer look at the system. Now again, substitution is not a good method because every single variable has a coefficient. I do not have a single variable. So my elimination is my second or is my right method. So let's see which one is easier to eliminate, the A or the B. Both of them have different variables that are not multiple of each other's. So B also has 4 and 9. They're not multiple to each other. So basically A and B are the same thing. Like you need to multiply the top equation by a number and the bottom equation by another number for you to have same coefficient but opposite sign so you can eliminate that variable. So I'm going to choose to eliminate A. So if I do that, then I have to multiply the top equation by a 5, because 5 times 3 is a 15. And I need to multiply the second equation by a negative 3, because negative 3 times 5 is a negative 15. And then since I have 15 and negative 15, they will cancel out. Now remember, if you multiply by 5, you have to multiply every single part of this equation by 5. And on the bottom, the second equation, you need to multiply every single part of this equation by negative 3. So let's go ahead and do the work. So let me delete this over here. Okay. And let's go ahead and multiply the top equation by 5. So let me write down the equation. And if I need to multiply this by 5, I will get 5 times 3 is 15a plus 20b equals 10. And let's multiply the bottom equation by negative 3. So you see the negative. So I will have two variables with opposite coefficients that will cancel out. So negative 3 times 5 is negative 15a minus 27b equals negative 3. Now if I add these two equations, 15a and negative 15a will cancel out. 20b minus 27b will be negative 7b, and 10 plus negative 3, that's going to be a 7. So as you can see, I eliminated the a. I end up with a simple equation with one variable that I can solve. So let's copy this into step 2. And let's solve for b by dividing both sides by negative 7. So b in this case is equal to negative 1. I just solved for one of the variables. Now in my third step, I need to plug in b in any of the original equations. So let me choose to plug it in the first equation. So 3a plus 4 times negative 1 equals 2. So 3a minus 4 equals 2, since 4 times negative 1 is a negative 4. If I add 4 to both sides, I will get 3a equals 6. Divide both sides by 3, so a is equal to 2. I just found the other variable. So my solution in this case is 2, negative 1. Now remember, always plug in both equations to check your solution. So let's go ahead and do that. So a is 2 and b is negative 1. And I need to check if that's going to give me 2. 3 times 2 is a 6. 4 times negative 1 is a negative 4. So 6 minus 4 is equal to 2. So yes, it works for the first equation. Now let's check if it works for the second equation. So 5 times 2 is a 10. Plus 9 times negative 1, that's going to be a minus 9. And that is equal to 1. So yes, it works for the second equation as well. So that is elimination. When you have two equations without a single variable, because usually substitution is the easier method. If you have a single variable, if you do not have a single variable, try to multiply the equations by a certain number that will eliminate one of the variables for you. Now, so let's review the steps really quickly. So you need to multiply. Step 1 is to multiply by a certain number to be able to eliminate one of the variables. Then you will end up with a single variable equation that's easy to solve, and you can find the first variable. Once you find the first variable, plug it back in any of the original equations to get your second variable. Always check your solution. That's it for this lesson.